Hello, I'm Professor John Kelly, and this is the Weber Auto YouTube channel. Today we are coming to you from our brand new building on the Weber State University Davis campus in Layton, Utah. Now today we are going to talk about the transaxle, the hybrid transaxle that comes in the 2019 and above Toyota RAV4 Hybrid. So this transaxle is called the P710 transaxle, and it is just a little bit larger version of the P610 transaxle that comes in the 2016 and above Toyota Prius. This is not the same transaxle that comes in the Toyota RAV4 Prime. It uses a P810 transaxle, and we'll talk a little bit more about that later in this video. I should also mention that this P710 transaxle comes in a 2018 and above Toyota Camry Hybrid, Toyota Avalon Hybrid, and a Lexus ES300h. This transaxle is coupled with a very fuel-efficient 2.5 liter Atkinson cycle engine. This is a very special engine that has a very high brake thermal efficiency rating, which means that it can convert almost 40% of the heat energy that it produces into mechanical energy. Now that may not sound very good, but for an internal combustion engine, that's really good. But in order to do that, it needs to operate within certain RPM and load ranges, and this transaxle can help it do that. So let's take a look at the parts inside this transaxle that help that engine maintain its optimum efficiency. So this transaxle has two electric motors. The electric motor that helps move the vehicle down the road is called motor generator number 2, this big motor right here. And so it connects to a gear shaft right here called the motor speed reduction gear shaft, and it has 16 teeth on it. And I will set that down in the transaxle case right here. And then the electric motor, MG2, sits right on top of that. There we go. Now that 16-tooth gear that this motor turns meshes with a counter drive gear right here. This counter drive gear has 49 teeth on it, and it drives the pinion gear of the final drive. And so we'll put this down in here like that. The gear ratio between motor generator number 2 and this counter gear right here is 3.0625, and we get that by dividing the 49 teeth of the counter gear by the 16 teeth of the motor reduction gear. Now this counter gear with the pinion gear on the top drives the differential assembly, and like any other transmission, front-wheel drive transmission, we have a differential to allow the front wheels to turn at different speeds while you turn a corner. So I'm going to set the differential case with the ring gear on it down inside here now. There we go. This ring gear on the differential case on the RAV4 Hybrid has 78 teeth, and the pinion portion of it has 20 teeth. That gives us a gear ratio of 3.9 to 1 between the counter gear and the ring gear on the RAV4. If it's the Camry or the Avalon or the Lexus ES300h, then there are 22 teeth on this pinion and only 76 teeth on the ring gear, and that gives us a gear ratio of 3.4545. So what we are looking at right now is a motor, an electric motor. This is the rotor of the motor. It sits inside of a stator back here in this transmission case, and the rotor rotates in this direction to make the vehicle move forward. So this is the front of the vehicle back here. This differential has the CV half shafts connect to it, and through your hub and bearing assemblies, your tires and wheels. And so when you see this gear right here rotate, just think of that as your front tires, because it rotates the same speed as your front tires. Now, the overall gear ratio between this motor generator number 2 and your tires to make them rotate one time on the RAV4 is 11.944 to 1. In other words, it takes 11.944 rotations of this motor, MG2, to get one rotation of your tires. Now, if you've got the Camry or the Avalon or the Lexus ES300h, then it's only 10.58 revolutions of MG2 to get one revolution of the tire. The RAV4 has more because it gives you a little bit more torque, a feeling of more power. Well, it is more power. It's torque multiplication in the RAV4 than you would have on the passenger cars. This motor is rated at 88 kilowatts, which is roughly 120 horsepower. It's also rated at 202 newton meters of torque, which is approximately 149 foot-pound force of torque. And it has a maximum RPM of 17,000. These really spin fast, and they spin fast because they use less permanent magnets in here, less of the rare earth permanent magnets. And so to make up for lower power motors, lower power rotors, they spin them faster at lower gear reductions or higher numerical gear reductions to get approximately the same power as the older hybrid transaxles that had the stronger magnets in them. The RAV4 Hybrid does have a rear electric motor. I don't have that here with me. If I can get my hands on one, we'll take a look at one in a future video. All right, so the final drive differential right here in ring gear can receive power from MG2 as you're driving down the road. Under any operating condition, it's either receiving power from the motor spinning as receiving power from the stator and the inverter assembly under the hood, or when you decelerate, the wheels and tires through the CV half shafts turn the differential case here, which forces the MG2 rotor to spin, and in this case, it becomes a generator. So that's where you can pick up some regenerative braking. So MG2 is either a motor as you're accelerating or trying to hold a steady speed, or it can become a generator when you decelerate. All right, now, that's one of two paths for power to get into the differential here to move the vehicle down the road. The other path comes from the engine through the second electric motor that this transaxle has. So this transaxle has another electric motor right here called motor generator number 1. And motor generator number 1 is not used to propel the vehicle down the road, but instead it is used with a planetary gear set that Toyota calls the power split device to control the gear ratio between the internal combustion engine crankshaft and the counter gear and the final drive gear right here. So let's take a look at this planetary gear set. Every planetary gear set has a ring gear, like this one right here. Sometimes it's called an internal gear or an annulus gear, but you can see it inside of there. This ring gear has 78 teeth. All Toyota hybrid power split device ring gears have 78 teeth, every single one of them. Then we have what's called a planet carrier. So we have these little planet gears right here. There's 3 of them. This piece that holds them or carries them is called the planet carrier, and it splines directly to a special torque limiting clutch pack that connects to the engine crankshaft. So what that means is this planet carrier spins with the engine crankshaft at exactly the same speed as the engine crankshaft. So that sits inside of this ring gear. And then we have a sun gear right here. This sun gear has 30 teeth on it, just like all Toyota hybrid transaxles have 30 teeth on the sun gear, 78 teeth on the ring gear, and 23 teeth, I believe, on the Planet Carrier, or on the Planet gears. All right, so this sun gear connects directly to the MG1 electric motor back here. So we have 3 pieces of the Planetary gear set. The ring gear on the inside is actually connected to this housing that has a counter drive gear on the outside. And that counter drive gear has 53 teeth on it. And so the counter drive gear spins with the Planetary gear set ring gear, and it drives the counter gear right here that turns our pinion and ring and makes the vehicle move down the road. So if this gear rotates, the vehicle will move. So let's set this down in the transmission now. So next, we take our Planet Carrier and put it down in the ring gear. The input shaft that hooks to the engine is going to go through into the bell housing underneath here. And so we will put this down in, get the gear teeth lined up, and down it goes. And then we'll take our sun gear with its 30 teeth and put it in the middle of that Planet Carrier and get its teeth lined up. And we've got a few bearings right here that go with it. And then finally, motor generator number 1. Oh, before I put on motor generator number 1, this transmission, like almost all Toyota hybrid transmissions, has a engine mechanically driven oil pump. So there's a drive shaft that connects to the Planet Carrier and spins with the engine that drives an oil pump in the side cover of the transmission. So I just wanted to show you that on the Planet Carrier before we put the motor on. But now let's put motor generator number 1 up here, and we will spline it right to that sun gear. So now if the electric motor MG1 rotates, the sun gear rotates, because they're splined together. The sun gear with the electric motor here, the Planet Carrier is turning, and it takes 3.6 revolutions of this motor generator number 1 to get 1 rotation of the Planet Carrier, or the 1 rotation of the engine crankshaft. So one of the jobs of the MG1 motor is to start the engine, and it just simply does that by turning faster than the Planet Carrier, and it takes 3.6 rotations of motor generator 1 to get 1 rotation of the crankshaft, and that's with the vehicle stopped. So these little bumps right here on this gear, those are that is the parking gear, and we have a parking pawl right here. Here's the parking pawl, and a little pin holds it in place. And when you put the transmission in park, this moves forward and latches into the parking gear. And that prevents the ring gear from rotating. That also prevents the counter drive and counter driven gear and final drive gear and differential from rotating, which means the vehicle won't move. So we'll take it out of park for our demonstration here. But MG1 has several jobs. As I just showed you, it can start the engine. Now, I showed you right there how it would start the engine with the vehicle stopped. But it can start and stop the engine at any vehicle speed. It just needs to spin at the appropriate speed to start the engine based on the vehicle speed and the RPM of all these other parts. All right, the second thing that motor generator number 1 does is it generates power to recharge your high voltage battery. It also generates power to feed power to motor generator number 2 under certain conditions. and that would be considered a series hybrid operation at that point if we have an engine-driven generator providing power to the motor that propels the vehicle down the road. So once again, it generates power to charge the high voltage battery. This does not generate power to charge the 12-volt battery. The high voltage battery provides power to a part called the DC to DC converter, which charges your 12-volt battery. This vehicle does not have an alternator. So that's a common point of confusion with the MG1 here, is which battery does it charge, and it's just the high voltage one. And then one of the biggest jobs that it has is to provide a variable gear ratio between the engine crankshaft and our countershaft and final drive here. So right now, if I were to reach under this transaxle and get up and grab that input shaft right that I showed you on the Planet Carrier and try to rotate it, I can rotate it. And notice with the vehicle stopped with us in park, all that does is spin motor generator number 1 3.6 times faster than the engine. And under those conditions, it can be a generator, or it could just be neutralized and free spin. But notice it's not making the vehicle move. This ring gear is not rotating. The vehicle's not moving. So in order to make the vehicle move with power supplied from the engine, motor generator number 1, we play some tricks with motor generator number 1's rotational speed and direction of rotation. So in any other automatic transmission that you drive, it has low gears and high gears. A low gear would be considered an underdrive gear, an underdrive gear ratio. And what that means is that the engine is spinning faster than the output shaft of the transmission to drive the wheels. The engine crankshaft is spinning faster. Then there's another situation called direct drive, where the engine crankshaft is spinning the same speed as the output shaft of the transmission. And then there's another condition called overdrive, where the engine crankshaft is spinning slower than the output shaft of the transmission. This power split device planetary gear set that we have right here can do all three of those and have variable, infinitely variable gear ratios in between. And so I want to walk you through the different modes of operation that this eCVT, electronic continuously variable transmission, has. There are 9 different modes of operation. This is a CVT, but it is not one of those belt-driven, either the push belt or the pull chain style CVTs that you read about in other vehicle manufacturers or even in other Toyotas. This is a much more reliable but more expensive way of accomplishing the same thing. So let's walk through the 9 different modes of operation of the eCVT transmission. Okay, mode number 1. We are in park, vehicle at a stop, the vehicle is off, and you reach in, step on the brake pedal, and hit your power button, and your ready light comes on the dash. At that point, the engine might start, it might not start. It just depends on the state of charge of the battery, the high voltage battery. So if it does start, I just showed you how MG1 right here will rotate 3.6 times for each revolution of the engine crankshaft, and it'll rotate at a high speed to get the engine started very quickly. So once the engine starts, then we enter mode 2, which is charging while stopped. So with the vehicle stopped, engine running, the engine is spinning, the engine crankshaft is spinning the Planet Carrier. MG1 spins 3.6 times faster than the engine crankshaft and acts as a generator as needed. You may have noticed that the engine will shut off after a while, then it'll start again, it'll shut off, start again. It's doing that to recharge the high voltage battery. The battery state of charge will come down to a certain point. Engine starts, uses MG1 to recharge the high voltage battery. Once it reaches a certain state of charge, then it shuts the engine back off. And it'll sit there cycling for days if you let it do that. I've left vehicles on over the weekend. Left on a Friday, come back on a Monday, and all of a sudden a Prius engine fires up. And it's like, oh, I forgot to shut that off. But anyway, that is charging while stopped. Mode 3 now is we take it out of park, put it in drive, and we're ready to take off, to start driving at low speeds. Under those conditions, the engine could be off. Let's say the battery state of charge is high. So when it's high, the battery will, through the inverter, will provide power to MG2 and propel the vehicle. And so it will turn MG2 just like this. Notice that causes MG1 to also rotate. What you cannot see is that the planet carrier or the engine crankshaft is not rotating, and this is just the electric vehicle mode. And depending on the battery state of charge, you can drive up to a certain vehicle speed as long as you accelerate slowly before the engine comes on to assist with that. So in mode number 4, the high voltage battery state of charge is getting low, and that battery provides power to MG2 to propel the vehicle. But if the battery state of charge is low, then we need to start the engine. And so MG1 starts the engine. When the engine is running, I'll spin the equivalent of the crankshaft here, the transmission input shaft, that planet carrier. Notice now the speed of MG1 has picked up. It's faster. And that's because it's acting as a generator to supply power to the battery and to supply power to the MG2 rotor to help move the vehicle down the road. Okay, mode number 5 is called constant speed cruising. And under those conditions, under low load, so you're not going up a hill, you're not going down a hill, you're just going on a nice flat surface. Under those conditions, the eCVT portion of our Planetary gear set here tries to let the engine RPM go to the point where it is the most fuel efficient for the existing load and vehicle speed that the vehicle is experiencing. If you look at this table right here, this is from a report published in 2019 from the EPA, the U.S. Environmental Protection Agency. They did a study of the thermal efficiencies, the brake thermal efficiencies of several different engines, and one of them was this 2.5 liter engine used by Toyota. And if you notice there on the chart, it has a maximum brake thermal efficiency of 39.8%. Now, at that 39.8% mark, you'll notice that the engine RPM at the bottom of the screen is approximately 2,500. And the amount of torque in Newton meters off to the left of the screen is 180, which is about 133 foot-pound force of torque. And then notice at the same time, that red arc coming down to the 50 kilowatt text there on the right-hand side of the graph indicates that the 39.8% of brake thermal efficiency is occurring while delivering 50 kilowatts of power, 50,000 watts of power. Well, we don't need 50,000 watts of power when we're just at a steady state cruise speed. We need less than that. It might be as low as 30 kilowatts of power. So if you look at this next chart, I have marked the lowest engine RPM and the highest engine RPM that we could use and still be at 39% brake thermal efficiency. I've also marked the highest torque and the lowest torque, so between 190 newton meters and 140 newton meters of torque, we will still be in that 39% thermal efficiency range. And that also, if you look on the right hand side of the graph, gives us anywhere between 25 kilowatts of power, which would be like for steady state cruising, clear up to 65 kilowatts of power. Okay, let's see how the Planetary gear set, or the power split device, as Toyota calls it, helps the engine stay in that operating range, that maximum efficiency operating range that we just looked at on the chart. So, if we look at the relationship between the rotational speed of the MG1 rotor, which is the sun gear, the engine crankshaft, which is the Planet Carrier, and the ring gear here, which is our counter drive gear, we can achieve and see how underdrive, direct drive, and overdrive occur. So in underdrive, which is what we want when we're accelerating, we want a low gear ratio, we just spin MG1 faster than we spin the counter drive gear. And the larger the difference between the speeds of those two parts, the higher numerically the gear ratio is, and you get really good acceleration. But as vehicle speed starts to increase, we bring the rotational speeds of these two closer and closer together until eventually they become the same speed. Now at that point, which in our example at 104 kilometers per hour or 65 miles per hour, that occurs at 1650 engine RPM on the RAV4 Hybrid. And so at 1650, the sun gear, the Planet Carrier, which is the engine crankshaft, and the counter drive gear all spin together as one assembly. Now, once we want to go a little faster and get into overdrive gear, then we slow down MG1 to where it's spinning slower than the ring gear or counter drive gear here. So we spin slower than the ring gear here, and that forces it to go into an overdrive situation. And eventually we will get to a point where MG1 actually stops rotating while you're driving down the road. And at 65 miles an hour, that actually occurs at 2109 engine RPM. So if you're driving 65 miles an hour, your engine RPM hits 2109, this motor physically stops moving, and that puts, if I turn the engine crankshaft here, that causes an overdrive situation to occur between the Planet Carrier and the ring gear here. Then, if we want even more overdrive, since the motor stopped and it was spinning in one direction, now we will spin it in the opposite direction. So all of this time, the underdrive gear ratios, we were spinning the motor in the same direction as the ring gear down below. But when we stop and want to go into more overdrive, we turn it in the opposite direction. So now they're spinning opposite directions, and that gives us an overdrive situation. So if we want underdrive, we just spin MG1 faster than the ring gear. If we want direct drive, we spin at the same speed. If we want overdrive, we spin it slower than the ring gear and slowed down to a point where it physically stops. And then we can turn it backwards to force an even higher overdrive gear ratio for maximum fuel efficiency. And what that does is it allows the engine RPM to be controlled by the rotational speed difference here, transferring torque to our final drive. All right, this also has a maximum RPM of 17,000. It can produce approximately 31 kilowatts of power in generation mode, which is about 42 horsepower. It has about 54 newton meters of torque, or 40 foot-pound force of torque. Okay, so that was mode 5 of 9, which is steady state cruising. In mode 6, we have steady state or constant speed cruising, but with a low state of charge in the high voltage battery. And in that case, we just speed up the engine to force MG1 to spin even faster to provide power to the high voltage battery that then supplies power to MG2 at the same time. And at that time, there's a combination of power being delivered to the final drive through MG2, through the counter gear to the final drive, and not only are we generating power by spinning the engine faster here for MG1, but some of that torque is also delivered from the engine to our counter gear to the final drive. So we have two separate paths for power to be delivered to the final drive here. Okay, mode number 7 is full throttle acceleration. And under those conditions, the high voltage battery supplies extra power to the inverter to help MG2 have all the power that it can electrically. And then the engine goes to an underdrive gear ratio through the Planetary gear set here to also help provide power, and we get maximum output potential from MG2 and maximum output potential with a variable gear ratio out of MG1 through the through the power split device to our counter gear to the final drive. Mode number 8 is deceleration. When you let off on the throttle when you are driving down the road, MG2, which it has been a motor up to this point, now becomes a generator, and it will induce current into the MG2 stator back here and send power back to the battery if the battery state of charge is low enough and needs it. Under those conditions, there's some physical resistance to rotating the MG2 rotor caused by magnetic fields opposing each other as it rotates, and that gives you not only regeneration of power but regenerative braking. It helps slow the vehicle. The same thing can occur when you move your shifter to the B or braking position on this vehicle. All right, mode 9 is just simply reverse, and we've talked about that already. We just turn the electric motor in the opposite direction. So that's reverse right there. Here's forward. No reverse gear, we just turn the motor backwards. All right, let's take a look at the rotors here just for a moment. There are 3 different transaxles in this series that look very much alike. There's the P610 that's in the Prius, the P710 that we're looking at right now, and then the P810 that comes in the RAV4 Prime. It's in the new Sienna van, and it's in the Highlander Hybrid. By comparison, the P610 in the Prius has a rotor, MG1 rotor, same diameter, but it's 24.3 millimeters thinner. The MG2 rotor in the Prius is 10 millimeters thinner than this one. But if we talk about the P810 transaxle in the RAV4 Prime, we've got jets flying overhead. Right next to an Air Force base, there's always something. If we talk about the P810 MG2 rotor in the RAV4 Prime, it's actually 36.5 millimeters thicker than this one, but with the same diameter, and its MG1 rotor is the same thickness as this one. So that will give the P810 in the RAV4 Prime and the Highlander and the Sienna more power, which it needs because those are bigger, heavier vehicles. And if you're driving in EV mode only on the RAV4 Prime, you don't have the additional power coming from the internal combustion engine to propel the vehicle. So you need a more powerful electric motor to give you the same feel, to give you the same acceleration, if not more, than you had with the internal combustion engine. Let's get the motors out of the way just for a moment. We're just about done. Let's take a look at the stators, the rest of the transaxle case right here. All right, this right here is a stator for MG2, and this is a stator for MG1. And each of these have 3 wires. You can see down inside here there's 6, there's 5 right here, a 6th one over there. There's 6 bolts. There are 3 wires, there are 3-phase cables for each of these stators. And the stators are what have current going through them that produces a magnetic field that attracts and repels the permanent magnet rotors that are in the transaxle and makes them rotate. These stators get very hot, and so they are liquid cooled by the transmission fluid, the Toyota World Standard transmission fluid. It has spray cooling. There's a tube right here and a tube right here, and this is the top of the transaxle. I've got it upside down. But it sprays transmission fluid on to the windings in the housing and the stator frame to help cool it with the transmission fluid. It has temperature sensors. There's one right here and one right here, one for each of the 2 stators. This has an oil pump, as I mentioned before. It has an oil pump pickup tube right here in the bottom of the transmission. And then the oil pump itself is in the front cover, or the side cover, of the transaxle. So here's the side cover, and if you look right there is the identification of the P710 transaxle, and the oil pump that's driven off of the engine crankshaft through the Planet carrier has its drive shaft sticking through right here and rotates with the engine crankshaft at engine speed. These 2 pieces right here are called resolvers, and they are the parts that measure the rotational speed, direction of rotation, and position of the MG1 and the MG2 rotors over there. These are serviceable. You have to replace them as a set, and then there's a scan tool function to go in and have it auto learn the position of the rotor's actual magnetic poles to the reluctors here in the side case. There's one more thing I want to show you about this transaxle, and that is these 6 wires right here. There's 3 wires right here for the MG1 stator and 3 wires right here for the MG2 stator, and these are where the current and the voltage are supplied from the inverter assembly that's on top of this transaxle under the hood. Now these wires are fairly thick, and they're a lot thicker if you look at this photo here in comparison with the P610, the Prius transaxle transfer wires, and I assume that the P810 wires are even thicker. It's just an indication of how much more power, electrical power, each transaxle uses. The P610 not using it near as much as the P710, the P810 going to use even more. Alright, as I mentioned before, the RAV4 Hybrid has a rear axle. It's actually called the Q610. I'll try to get my hands on one of those, and I'm still looking for, and always looking for, the P810, but it's so new, they're hard to come by. And as soon as I get one, I'll tear it apart and show you what's inside of it as well. Thank you for watching.